Okay, I'm going to go over chapter 12 now. Chapter 12 is on experiments. It talks in the beginning about observational studies, which is different than an experiment. So an observational study is when the researchers don't choose the choices. They usually, most of this time, most of them are retrospective, which means they use data that's already out there to study it. Sometimes in a prospective study, they identify the subjects and then collects data, but these are observational studies, are not experiments. So again, in observational study, they don't assign choices. They simply observe what came out of it. If it's retrospective, they take data that's already been collected. They can do it, evaluate it any way they want to, but it's data that's already there. They're not starting anything on their own. So it's based on historical data. If it's prospective, they select the subjects in advance, but they don't determine what they're going to do to those subjects. They're going to just take data that comes up on those subjects. So that's an observational study. Mostly you're just looking at numbers that somebody else came up with. Now, if it's an experiment, then you're controlling everything. So you're manipulating the factor levels to create treatments. We'll talk a little bit about what a treatment is. You randomly assign students to it. Again, random is important, and then you evaluate the results. So random assignments, you assign which groups, which members of each group to do the treatments. The factors is what it is you're going to be checking. The factor is what it is you're going to be doing to each one, like how much of this I give them, how much of this I give them. You change levels, that's manipulated by the experimenter, so you decide, okay, I'm going to do this much with this group, this much with this group, this much with this group. You're going to try to evaluate the differences that happen with that factor. So the factor is what it is you're testing on. The response variable is the data you're going to look at. Like if you're deciding about fertilizer in plants, how much fertilizer. Your response variable is how much the plants grow. Your experimental units, that's the subjects you choose. So if you take 3 from this group and 3 from this group, those are your experimental units. And the level is the specific values that they're choosing for a factor. So it's like 10 milliliters of this, 20 milliliters of this. That's the level. And then the treatment is what it is. It's kind of the procedure of the experiment, what it is you're doing. Are you giving these plants fertilizer and then letting them grow? That's your treatment. There's 4 principles of designing an experiment. First is the control. You must have something in there that you don't do anything to, that's just treated normally, because you want to be able to compare it. Did it change from what it normally would? So control, it can have different things, but it doesn't change anything about the factor that you're checking on. Randomization. You have to have it random, otherwise you don't know whether what you come up with, the data, is just because of certain things or not. So randomization, just like we talked about in the last chapter. Replicate. You don't want to do just one set of experiments. You want to be able to repeat it and show that when you repeat the experiment, if you do it all again, you'll get similar data for it. That's what replicate means. So you must apply it to a number of subjects, so that you don't see it just happens with this one or this one or this one. So you want to do more than one subject. That's one way to replicate it, do more than one subject. And then again, as I mentioned, also repeat it again with maybe a different population to see if the data stays consistent. Now, block is when you want to have it randomized, but you want to take out some other factors so that you can see, is it just the factor you're testing? Is that the one? Is that the response variable you're going to get, or is it due to something else? So even though you want to have a control and you want it to be random, you have to block it so that you can't say, well, this might have influenced it also. For example, if you wanted to study kidney disease in dogs, so you control, probably want your size of, control the portion size, so each dog's getting the same amount of food, so that it might not be due to a different amount of food. You want to standardize other factors, like do they all have the same, live in the same kind of environment? Do they have the same amount of water, same amount of exercise, play, sleep time, etc.? That's the control. or no, that's the standardization, sorry. Um, you might restrict it to a single breed of dog. You might assume it to just adult dogs because there might be some variations between breeds, might be some variations between age of the dog. And you want to assign the dogs to different types of feed. So if you're testing a certain food, different portion of food, whatever you're checking, if you're doing it with different foods, then you want to assign the different types of food randomly. And then make sure you have more than one dog for each one. So like if you're feeding one of them Alpo, you want to have more than one dog in that one so that you can compare the results for all the dogs. And then you might repeat the experiment with different breeds. If you do one with golden retrievers, maybe you want to repeat it with schnauzers. If it's completely randomized, that means all the experimental units have an equal chance of receiving a treatment. So it's like drawing things out of a hat. Every one of them has an equal chance to be a treatment. Here's another example. This is you have an ad for plant fertilizer. This claims that it will grow juicier, tastier tomatoes. You want to test that and see if that's true. You'd also like to test, see what if I used half the amount of that fertilizer would still. So first you come up with a plan. The plan is to see whether tomato plants treated with the fertilizer are juicier and tastier. Your response variable, you need to have some way to measure whether they are. So maybe you have a plant panel of judges that's going to rate the tomatoes on their juiciness, on their taste. The treatment, the factor for the treatment is the fertilizer. So you might grow the tomatoes in 3 different levels. Some with no fertilizer, some with half the amount, some with the full amount. Experimental units. Well, that's the tomato plants you're going to check. So let's say you pick 24 tomato plants, all the same variety of tomatoes. For your experimental design, first you want to have control. So you want to grow all the plants in the same area, same amount of sun, rain, temperature, treat all the plants equally. That way you kind of block out any other things that might affect your results. Replicate. You might use use 8 plants in each treatment group. And then randomly assign them, like number the plants 1 through 24. Use your calculator as a random number generator to pick which plants go in which group. You can't see this very well, but here's your 24 plants. You have your group. Here you have 3 groups of 8 here. Here, like some were treated as a control, so you didn't give them any fertilizer. Here you gave these 8 half the fertilizer. Here you gave these the full amount. And here at the end, for your response variable, you compare the juiciness and the tastiness. You're going to have to consider some other things like how do you know when the tomatoes are ready to judge? Is it a certain size? Is it a certain color? Whatever. You need to specify that so that they're all tested at the same time. You need to display the results. So you need to put them out so you can see them, get an idea, display them in some way where you can find some evaluation of them, then evaluate your results. Sometimes one measure at the end of an experiment is whether it's statistically significant or not. That means your results are different enough that it can't be attributed to normal variations. So you look at it and say, well, these tomatoes were just a little juicier here. That might not be statistically significant. You want something that is more concrete. You might use box plots here if you did your data. Like you can compare these two and say, okay, does it look like it made a difference? Well, yeah, it looks like it did. Like this one, it moved it all up a little bit, moved the median up a little bit. This one looks like maybe not, because the medians are about in the same place. The boxes are very similar. Now the 2 extremes are a little bit different. Here's another example of experiment: gastric freezing. To treat people with peptic ulcers, they used to take an inflatable bladder, put it down your throat into your stomach, and then put a very, very cold liquid into the bladder to try to relieve the effects of the peptic ulcer. Well, now an insurance company gives a notice. Gastric freezing for chronic peptic ulcer is non-surgical. It was popular years ago. It's not used much anymore. Had a lot of complications. It gave only temporary improvement and a lack of effectiveness when tested by double-blind controlled clinical trials. So a lot of stuff there. So they did an experiment with this. They decided it really wasn't a good treatment. So what is the factor? Well, for A, what is the factor? Well, the factor is which type of treatment they used. So maybe they tested some with this gastric freezing, some with other methods. B, what's the response variable? Well, they measured how much relief they got. They measured maybe how long it lasted. That's a response variable. What were the treatments? Well, one was the gastric freezing, then some other alternative treatment. You want to try different things to say, okay, did the gastric freezing really make a difference? How did they decide which received treatment? They assigned them randomly. Again, randomization. Were the results statistically significant? No, because notice it says there was a lack of effectiveness. So it was not statistically significant. We talked in the last chapter about sample surveys. That's mentioned here. To try to estimate your population parameters, you do sample surveys, and your sample needs to be representative of the population. Here again, talking about experiments, they're trying to assess the effects of treatments so that they're not always drawn randomly from the population. The randomization is in assigning the subjects to different treatments. That's the important thing, assigning the subjects to different treatments. A control group. A control group is a group that receives no treatment or just a baseline treatment level. You want to compare the results to that. Before I talk about blinding, let's go down to placebo. You've heard of a placebo before. A placebo is something you have no effect if you administer it to a group. It's like if you want to test a certain drug. Well, you give some of the people usually you say a sugar pill. Sugar pill had no effect on anything. So if they get this pill, they don't know whether they're getting the sugar pill or they're getting some other thing. So that's a placebo. It's something that really is going to have no effect, and they know it. But it's important to have that in your study. Now, blinding. Blinding, there's two levels of blinding. One level is you want the subjects to not know whether did I get the drug or did I not get the drug, because that can affect your results. That's a single blind. It's very common in a single blind. You give people, like in a clinical trial, you give some of them a treatment, some of them don't get the treatment. So that's single blinding. Then another way of blinding is so that the people evaluating don't know who got the treatment and who didn't, because they might have a tendency to say, well, if they got the treatment, maybe they should do a little better or not. Now, it's a double blind. So single blind is where the person in the experiment doesn't know they had it. A double blind was when the person doing in the experiment doesn't know whether they got the drug or not. Also, the people evaluating the treatment don't know who got the drug and who didn't. Double blinds are very, very important when they can be done. Sometimes you can't do a double blind, but most things with, like, especially drug things, are double blind studies. Sometimes with the placebo effect, you can give somebody the drug, and if they don't know that they didn't get the drug, they might get better because they think they're going to get better. It says there's a tendency of subjects, 20% or more, that have a response even though they got the placebo. Years ago, there was a TV show called MASH about a surgical hospital in the Korean conflict, and in it they ran out of painkillers, so they gave the kids these sugar pills and told them it was a really, really strong pain medication. Now, granted, this was just a TV show, but some of the soldiers, the injured soldiers, said that their pain went away because their mind convinced them. That's kind of the placebo effect. The best experiments are randomized. They're comparative, so you can compare one to the other. They're double blind, and they're placebo controlled. Blocking. This is different than the block we mentioned before. This is blocking. Blocking is when you take a bunch of experimental units that are similar and you put those into one block. Then you randomly assign your treatment groups within that block. So if you have a block of 24 similar things, you have 8 of them do this, 8 of them do this, 8 of them do this. And then randomized block design, you randomly assign the subjects treatments, but only within those blocks. Matching. Subjects are matched because they are similar in ways that you're not studying. So if you're studying relationship with a certain thing, you want it to be similar in all the other ways except that one thing. Like here's an example. In a retrospective study of music education and grades, they associate a student who studies an instrument with somebody of the same sex who is similar in family income but didn't study an instrument. So they make sure other things are the same except the thing they're trying to study. It's kind of like when we talked about stratifying when we were doing sampling in the last chapter, where you kind of associate people that are similar. Some other examples. Here again, back to the gastric freezing. What does it that mean that was double blinded? Well, that means the patients didn't know whether they got the gastric freezing or a different one, and the people evaluating didn't know which one got the gastric freezing. Here for part B, why would you recommend a placebo control? Well, because of blinding. An example would be even if you pumped fluid into them, now they would probably know when they got the fluid pumped in, but maybe you didn't use freezing liquid. Maybe you used something warmer, so they may not know that which one they got. And then C, suppose the researchers might think, well, it might depend on whether the person, whether it was a recently developed peptic ulcer or something they'd had for a long time. How might you design the experiment? Well, you might do blocking then. Put all the subjects that just got the ulcer recently in one group, and then randomly assign the treatments within that group, and then make up another group with people who had had the peptic ulcer for a long time, and randomly assign them into groups from that one. The next thing, a completely randomized two-factor experiment. You want to double the treatment groups so you can evaluate different combinations of factors. So you might say, well, if you're testing a drug, if I put these two drugs together, is that different than if I put this drug together with a different drug? So that's a two-factor experiment. The last thing is confounding. Here you have to be very careful because sometimes you might put something together and not realize that something other than your factor was being tested here. The example given here is, let's say you had an option for two credit cards. One has a very low interest rate, and no fee. A second card has a higher interest rate and a $50 annual fee. So if people got the low rate, no fee card, was it because of the low rate or because it was no fee? You don't know. Did they take it just because it had no fee? Did they take it because it had a low interest rate? You're not sure. Here, the more common thing with this one would be if one card had a low interest rate but an annual fee, and the other one had an annual fee but a higher interest, if the other one had a high interest rate and no annual fee. That's usually something you have to choose have to choose with credit cards. Another example here is, let's say you're teaching a class, like a semester class. So you have your first semester class taught for seniors. You teach it a different way. You teach it a certain way. Second semester, you want to see which way is more effective. So you teach second semester a different way. And you look at your results. Well, are those going to be statistically significant? Maybe not, because seniors might have a different attitude first semester than what they do second semester. So that might affect. It might not have everything to do with the teaching method. It might have to do with the attitude of the seniors from first semester to second semester. So that's just a real quick thing about experiments, different factors of experience. All right. Thank you.